Hello everybody. This is a short video regarding Nernst equation. Children, we will be discussing Nernst equation in a nutshell. See, as you can see, there is a Nernst equation written on the board. You all must be knowing that E naught cell is the standard reduction potential, R is the universal constant, T is the temperature in Kelvin scale, N is the number of electrons involved, and F is Faraday's constant. Now, we know that Faraday's constant is 96500, T is 298, R is 8.314. At the same time, the reaction quotient is actually the concentration of oxidation half cell upon the concentration of reduction half cell. Now children, when you put these values of R, F, T and 2.303, you will get the value as 0.0591. Now you all know this formula, but I would recommend that please write this equation first, put the values and then write this equation. Once you have done this, it will be considered as solving the question partially. So even if your question is not accurate with the marking scheme of the board, you will still get some marks for solving the question. Now children, there may be a number of questions. The first question which I believe you must know is this one. Here the question says we have an equation and we have to write the Nernst equation and the cell representation for the same. Now see, everything given before this arrow is actually your reactants and these are products. Now we have to write the oxidation half cell first and the reduction half cell second, both to be separated by a salt bridge. So here we can see that chromium is being oxidized to Cr3+. So we will be writing Cr by Cr+3. Then we have a salt bridge. On the other hand, Cd2+ is being reduced to Cd. Now this is oxidation half cell and this is reduction half cell. So first part is to write the cell representation. This is done. Many times children know everything but they fail to identify which should be written first, which should be written second. So first be careful. You have to write the oxidation reaction first, then the salt bridge followed by the reduction half cell. I hope this is clear children. Moving on to the next question. Now say, here we have a question which says calculate the EMF, the standard Gibbs free energy for the following cell. So first thing you have to do is to write the balanced chemical equation. So here the equation will be Zn plus Sn2 plus gives Zn2 plus Sn. Now before proceeding, you have to check if both the ions have same electron required for oxidation and reduction or not. In case it is not so, we have to balance, but this question we have both ions having 2 valency. So it's quite easy to solve. Now we will be writing the Nernst equation. E cell is equal to E naught cell minus 2.303 RT upon NF multiplied by log of concentration of oxidation half cell, that is Zn2 plus upon concentration of reduction half cell, that is Sn2 plus. Since the balance equation is not having any stoichiometric coefficients for the ions, so we will be not putting any powers here. Now, we all know that E naught cell is E naught cathode minus E naught anode. Minus 2.303 into 8.314 upon 2 into 96500 multiplied by log of the concentration of Zn plus 2 is given, children, 0.001 molar. So we will be writing 0.001 upon the value for tin is 0.1 molar. So we will be writing here it as 0.1. See, is this clear? We put the values of reduction potential of the cathode half cell, which is minus 0.14. Then the reduction potential of anode half cell, which is minus 0.76. Further, we also solve this part and we get the answer as 0.0591 upon 2 multiplied by log of 10 to the power minus 2. Now, further, this comes out as 0.62 minus 0.05 minus 0.0591 upon 2 multiplied by minus 2 log 10. Now, we very well know that log 10 is 1. On further solving this, we get the answer as 0.679 volt. Please make sure that you have balanced the equation before applying Nernst equation. Also make sure that you first put these value and then write this. These two steps will be considered as solving this question partially. So even if the question is not correct till the end, you will still get some marks for solving this. Also, do not forget to write the value along with the unit. In case you have not written the unit, you will not fetch any marks for the answer as per the step marking pattern. That will be all for this question. I hope this is understood. Moving on to the next question, children. As you see, this question also asks us to calculate the EMF of the solution. But the question is especially in two ways. First thing is, we have different charges on the anode ion and on the cathode ion. Say iron has 2 plus and hydrogen has 1 plus charge only. So this will be requiring 2 electrons, whereas H plus will require 1 electron only. So unless you get this right, you have to balance the equation first thing. Also, this particular equation has a gas involved. So for gases, we will be using the pressure of the gas instead of the concentration. So see, we apply Nernst equation. E cell is equal to E cathode minus E naught anode minus 2.303 multiplied by 8.314 into 298 upon N into 96500 multiplied by log of Q. Now before writing Q and N, we need to balance this equation. So we will be writing this equation as Fe plus 2H plus gives Fe2 plus H2. Now we see hydrogen has a stoichiometric coefficient of 2, which makes the number of electrons involved as 2 only. In the next step, we will be writing that E cell is equal to. Now E cathode is hydrogen, and children, we all know that the reduction potential of hydrogen is taken as 0 volt. So this becomes 0 minus 0.44 minus 0.0591. Now we have solved this and put the value n as 2 multiplied by log of Q. Now Q is the concentration of the product divided by the concentration of reactant. So in this case, we will be writing the concentration of Fe2 plus and also the pressure of H2 upon the concentration of H plus only. But the stoichiometric coefficient of H plus is 2, therefore we put a power as 2. As far as Fe is concerned, it is a pure solid and the concentration of pure solids are taken as 1. Therefore, writing Fe or not will hardly make any difference. I hope this much is understood, children. On further solving the question, we get the standard cell potential is plus 0.44, and as the concentrations are given as 10 to the power minus 3 and 1 atmospheric pressure. Also, the concentration of the reduction half cell is given as 1 only. We have placed the value, and when we solve this, we get this out as 0.44 plus 0.08865, which further comes out as 0.5286 volt. Another question comes out from this part, children, where we are supposed to calculate the standard Gibbs energy change for the process. Now as you see, copper is being reduced and iron is being oxidized. We have the standard reduction potential of copper and that for iron. Now first thing we have to do is to calculate E naught cell, and E naught cell is given by the relationship E cathode minus E anode Now we have the value of the cathode half cell given as plus 0.34 and that for the anode half cell as minus 0.44 volt. On further solving this, we come out to the conclusion that the answer is 0.78 volt. Further, we apply delta G naught is equal to minus NF E naught cell. Now, for the given reaction, both copper and iron are having the same oxidation state, so we need not balance the equation separately. We have to put the value as 2 only. So minus 2 multiplied by Faraday's constant 96500 multiplied by 0.78. On solving this, we get the answer as minus 150.5 joules, which is the correct answer. Sorry, it is kilojoule. I hope this is understood, children. We have another MCQ on the screen. Now we have a cell which is magnesium gets oxidized to Mg plus 2 and Cu plus 2 gets reduced to C. And we have to find which of the following is correct. Now first one says magnesium is cathode. And children, you must be knowing, I give you an easier formula to remember, an ox and red cat and ox and red cat. N for anode, ox for oxidation, and red for reduction, and cat for cathode. So this will help you memorize that oxidation occurs at anode and reduction occurs at cathode. Now this says magnesium is cathode, but it is evident from the cell representation that magnesium is getting oxidized. So magnesium will be anode, thus the first option cannot be correct. The next one says copper is anode. Has copper being anode, so copper is supposed to get oxidized. But we see here that Cu2 plus is getting reduced. So copper cannot be anode. Now the cell reaction is given as Mg reacts with Cu2 plus and we get Mg2 plus along with Cu. Now as it is evident, magnesium is transformed to Mg2 plus and Cu2 plus is transformed to Cu. So the third part is okay. But pay attention. This question appears like there are two correct answers. It says copper is oxidizing agent and you might be thinking that it is present in the reduction half cell, so it is the oxidizing agent. Yes, oxidizing agent is present in the reduction half cell, but children, it is Cu2 plus, not Cu. And the statement says Cu is the oxidizing agent, thus this is also not correct. So out of the four, option number 3 is the correct. Please be very careful while you do this question. Thank you.